Hey everyone, I hope you all are doing good and having a wonderful day. In this video, I'm going to show you that how we can find insecure deserialization in web applications and how we can escalate this to remote code execution. But as always, before diving deep into this video, if you haven't checked out my previous video where I have spoken about what insecure deserialization is, how it works, what are classes, what are objects, and all sort of things. So I've covered everything in that particular video so that you'll be able to understand everything from the very basics. So if you're really interested into learning insecure deserialization to its core, go ahead and check out the video. The link is given in the description, as well as you can see it at the right side of the screen. And now with that being said, let us get started. Okay, so as you can see, this is like an application that I have created, which is replicating the exact scenarios in which you're going to find insecure deserialization. Also, to let you know, I have created this lab in Node.js application. So it's a bit different from Python, where we have learned how we can find like insecure deserialization in Python in the previous video. This one is a bit different because here we'll have Node application, and we'll try to see that if you want to test for insecure deserialization in Node application, then what are the things that you should be looking for. Okay, so as you can see, we have an application right over here. We'll simply try to go ahead and log in. So I'm going to log in as administrator, admin and admin 123, and I'm also going to turn on the intercept because I want to check what's going on. Let's click on sign in. Here we have the request. Let's intercept the response, and you can see in the response we have some kind of cookie getting set, right? And then let's forward this, and it's going to dashboard. Let's turn everything off, and here we are at the dashboard. Now we'll try to go to, for example, my profile. Okay, and then we'll try to simply capture this request and send it to repeater. Okay, because we want to first understand how everything is working. So the very first thing that you should be noticing in this application is that the session parameter in the cookie is having something encoded in base 64. And how do you think I was able to understand this? Is because the value is starting with EY, right? So it's a note that whenever string is starting with EY, there's a very high possibility that that is encrypted or encoded in base 64. Okay, so let me just first send the request. Let me just remove this particular header, send the request right here, and you can see these are the response that we've got. And we can see that in the profile we are getting the response, the username, the name, the username, and all the details of this particular user, right? Like the role and email and everything. Okay, it's well and good. Now let's try to inspect what is here in this in the cookie, right? We can send this to decoder, and we can try to decode this first as URL because it's not properly be a base 64 encoded, and now we can decode it to base 64, and we can see that this is the value which is getting rendered in the cookie itself, right? So the very first thing that we can do is, like, this can also be a case of broken access control if the application is not checking the rules and everything properly. Okay, but apart from that, let's try to manipulate one of these values from Alex Johnson to, let's say, Fayaz, which is my name. We'll encode it to base 64. Let's copy this out and paste it here, and let me just see if the value is getting reflected somewhere or not, and send the request. And you can see the value is getting reflected right over here, right? Now there are n number of ways through which you can find a vulnerability in this application. Maybe this application is vulnerable to SQL injection. Maybe I can see this application might be vulnerable to cross-site scripting. We can just go ahead and try it out. Like, let's simply go ahead and try to do h1 test. Okay, let's copy this from here, and we can paste it right over here just to see if there's any vulnerability. And as you can see, this value is getting rendered, so we have our cross-site scripting vulnerability right over here, right? Now the thing is that in Node.js application, or in many application that is using MERN stack in the as their framework. MERN basically stands for Mongoose, which is the database; Express, which is the framework in which the application is created; R is basically React, which is the front-end part; and N is basically Node. So whenever the application is developed into MERN or any similar applications, there is a possibility where we can, if you are seeing like a JSON data getting sent into the request through any means, maybe it is there in the request body, whether it can be in the cookies, for example, right here it's in cookies, or whether it is in a normal post request, right? In all of these cases, you have a possibility of testing whether the application is vulnerable to insecure deserialization or not, because maybe the way it is parsing the JSON is basically by deserializing the data. Okay, so that can be the case over here. So let's try to go ahead and see how we can validate first that this application is vulnerable to insecure deserialization. Okay, so the very first thing that we are going to do is, because we know that the values of name, email and everything is getting reflected, I'm going to test with name. Okay, and there is a magic function, you can say, similar to what we have discovered in Python. If you remember, in the previous video we have discovered a reduce function in Python, right, through which we can tell the application that you don't need to treat this particular value as string, instead try to construct an object around this, right? And using that we were able to find the insecure deserialization vulnerability, which allowed us to do a remote code execution at that time, right? But in Node we don't have the reduce functionality or the reduce function or method. Instead here we have something like this. So this is a similar function. This is a similar function to reduce, where, for example, if we pass this value into the application, this is not going to be treated as string. This is the application. If the application is vulnerable to insecure deserialization, it will try to execute whatever function we are going to define after this particular keyword. Okay, so let's create a small function over here in Node, and the function is simply just going to return Batman. Okay, and just validate whether the Batman is reflecting here in the response or not. And we can see Batman is nowhere reflecting in the response. And if the application is vulnerable, if the application is parsing our value, or it is vulnerable to insecure deserialization, we should be able to see Batman. So we have encoded this. Let's copy this out, paste it into the cookie, send the request, and as you can see, okay, sorry, it's my bad, just one small thing is missing. We need to call the function over here. Let's do a call like this, and now let's paste this value here, because right now you can see this is kind of treated as a string. Okay, but we want to call this function, so send the request, and now you can see that the function was actually called, and the function was returning Batman, which is what is getting reflected over here, right? Earlier the function itself was getting treated as a text, but now you see when you try to call it, we're able to see the output, which is Batman, right? So this is, when you have discovered this kind of thing in an application, already insecure deserialization is confirmed, right? Let's try to go ahead and see that how we can convert this into a remote code execution vulnerability. So let's go ahead and check it out. Okay, so this is the final payload that we're going to use in order to execute remote code execution command. So you can see we have the same function, but this time we are first importing a library, which is child process, which is used to execute system commands using Node and JavaScript. And this is the method execute sync, right, which is going to execute the command. And here we have given pwd, and we are simply converting the output, whatever output the application is given, into string, so that it can be rendered into the front end without any issues at all, right? So this is the simple payload that you can use. So if everything works, then we should be able to execute this pwd command, and we should be able to see where the current directory is, right? Let's copy this payload from here, go back to repeater, and we can paste it right here, send the request, scroll down, and you can clearly see right over here we have successfully got the output of the pwd command, confirming that finally we can execute system commands, and finally it can give us remote code execution vulnerabilities, right? We can go ahead and test out some other commands as well, like ls, for example. Let's copy this, let's go back to repeater, let's paste it right over here again, and you can see that we are successfully getting the output of ls command as well. So this confirms that this application is deserializing the user's input without proper sanitization, leading to this kind of vulnerability, right? So the takeaway from this video is that if you are testing an application in which you are seeing that the JSON data is getting sent to the server, it's always a good shot to try out and see how it is handling some sensitive or interesting keywords like and function, and whether the value that you're giving into the function is getting called or not. If it is getting called, then there's a very high possibility that that is a case of insecure. If you have any doubts, if you have any issues, feel free to let me know your doubts or issues in the comment section. And now, with that being said, keep learning, keep hacking, and thank you so much for watching this video.